Welcome to my tutorial series. This is Shakil Ahmed. We were just discussing about producing survey weights and using weighted survey weighted data for summary statistics and other statistical analysis. So in this tutorial, we will see how we can analyze qualitative data with survey weights. So first of all, we see how we can estimate survey weighted proportions for a binary variable. So I'm just starting with the same data set, National Health and Nutrition Examination Survey data, and we have I have just called these libraries which I need for uh, summarizing data, and Haven is used for importing data from data, and survey variable is required for survey weighted analysis with geotools, remotes, and SVEPMICS. Data are used for making different tables and appropriate statistical presentations when you have weighted data. And then I just produce the survey design function using SV design function, which consists of ID, and that is primary sampling unit ID for some primary sampling units, as I discussed in the last lecture, and then weight. So this is a weighting variable included in your data set, and then stratification variable, that is data. So this you need to run this function first, and you will get an object as design that I just represented it as design. So I have already run these commands, so I don't need to run again. If you want to run, you can just see, for example, summarize survey design, and you can rename the variables you have already. And then now we are starting with the options. This function is basically used when you want to uh, produce your results without scientific notations. So just will run this command so that you will get the frequencies, the proportions in simple general number instead of scientific notations. And then I'm just producing a table, survey table for 6, and design is survey design. And then I'm just writing the proportion of the values. You can just use rbind command, or you can use, I think, data.frame command to join the two tables. One is this simple survey table that consists of frequencies, and the proportion table that will produce weighted proportions from the same table. But here I am writing two, that is I am rounding my results to the up to 2 decimal places. So let's see. So I have a table that is 6, 1 and 2, and then frequencies, and then the 6 ID is again repeated, and then frequency 1. So these are the this is the table you required for a binary variable when the variable has two categories. Even you can use this command for multinomial variables having uh, more than two categories. Just we can see for uh, income, which has, I think, already which has three categories: data.frame, and then this is the survey table that consists of frequencies, and this is consist of the proportion of the same table, same frequencies using uh, data.frame. Basically I am just writing the two tables uh, in form of one table. You can just run and see. So I have we have frequencies, and then we have percentages that is rounded to two decimal places. Similarly, you can add the frequency for more than two variables, just adding sex plus income, uh, and you will get the table in long shape. And similarly for education, you can use cbind command for the same purpose. Let's check. Yeah, that's also, I think, pretty good. You have just frequencies and then percentages for a variable. That is education. There are three categories, and you have frequencies for all three categories, and then uh, percentages rounded up to two decimal places. So note that when while using this option command with sci pen is equal to one leg, it's giving no scientific notation. So it is easy, and the answer is rounded to three decimal places. Can be rounded to three decimal places, and you can extend it to 4, 5, and 6 as you need it. So this is just a frequency distribution table for only one variable. When we can make two a table using survey design command, survey for survey weighted data like cross tabulation. So you can use survey table and then proportion table. You can get by using just survey table command, you will get the uh, frequencies, and then using the proportion dot table command, you will get the percentages as well, and you can write the two things, proportion and frequencies, both separately. If I run just this command, this will give the frequencies for two-way classification, where sex is on rows and education is on column. This is two-way classification. And if I want to make a proportion table, and the one means I am just finding the proportion with respect to rows, means on the basis of row total. For example, I am just adding all these and divide this by row total, not column total. So in this way you will get a frequency table proportion for row wise data. You can see if you add all these three proportions, you will get an answer of 1. So we are making proportions row wise. Similarly, if you want to make proportion column wise, then you can just write 2. It will give you proportions at column wise. So this is basically the frequency distribution, and you can again write using cbind command the frequencies as well as the percentages. If I have a code, you can just show. Similarly, you can make such table for education, uh, and other variables as well, and you can find it weighted uh, chi-square value to check the association between the two variables. You can just use the chi-square SVY chi-square function, basically survey weighted chi-square value, that will give you the chi-square value and the p-value. Now the p-value is very small as we have used the SCI pen command. That's why it's not showing in scientific notation. That's a good thing. You can just write it as less than 0.001. So that is your uh, a test of association. Uh, there is no significant association between sex and education. You can say it is statistically significant. Basically, H naught is rejected. It means the two variables are associated, and you can use the adjusted wall test instead of chi-square test. This is an alternate, and you can use other options as well, like Fisher exact test and other type of other variants of chi-square test using just you can see the documentation of SVY chi-square. So this gives almost the same result. You can just compare uh, the chi-square value is and the f value is this is using basically f statistic and this is using chi-square statistics. So that is 116 and the f value is 29 and this is also giving the significant result. It means there is an association between sex and education. Often we want an estimate in a set of subpopulation like using survey by. For example, we just want mean by age or by income or age and income. So we just need to find the average age of person for female and male separately. So you can just use survey by command and here I am just finding age, average age, basically mean of age. I am using the survey mean. It means I am computing mean of age and income by ethnicity. Means I am we will get the mean, average mean and average income for all individuals within different ethnic groups. So let's say if this ethnicity variable is labeled, then you will see the exact mean for all categories. If this is not given, then you can just at least you will get a numeric label and you can see the mean for different classes. So I have not yet labeled the classes. So you can see for ethnic group 1, the mean age is 28.6 and mean income is 14.1 and standard error of age is zero point 0.4 and standard error of income is 0.796. So you can add more variables and you will get uh, these details for all variables. So this is an interesting thing which researchers are always interested uh, to produce average for different subgroups, subpopulations. And the survey by command will adjust basically the proportions or the means for different cells for different subpopulations after adjusting the weights accordingly. That is important basically. Even you can find overall weighted mean uh, by ignoring weight. Then it is more sensitive to produce weights for subpopulations using uh, by ignoring weight is more sensitive, and the result will differ if you use survey weight command or without survey weight command. So you should be careful while applying the survey weight while analyzing the subpopulation analysis. You need to definitely use the survey variable command when the data is when the sample is taken using a complex survey design. So similarly, you can see a median age. For example, you can find quantile that is zero point 0.5, survey weighted median by ethnicity. We will get median ages for all groups. You can see 26 for group 1, 31 for group 2, and so on. And these are the standard errors. And then we can also perform two-way stratification, like we are stratifying with respect to sex as well as ethnicity. Then you can just see uh, we are obtaining mean. Basically I am using the survey mean. You can also find survey quantile or survey standard deviation or other statistics. And the groups are sex plus ethnicity. You can add more variables here, plus for example you want to stratify with respect to three variables. Here is we are cross stratifying with respect to sex. For example, I am keeping sex on row and ethnicity on column, then it will be a two-way stratification table. So this will provide average mean and average income for all subpopulations, basically for all cells. Let's see how we can see the results. It's taking a little time, and here you have sex 1 means for male and ethnic group 1, the average age is 28.7, and for female with ethnic group 1, the average age is 28.6, and this is the average income and the standard error of age and standard error of income. So this is that we have all possible interactions, basically age 1 income 1, age 2 income 1, age 1 income 2, and these are all possible subpopulations when we are stratifying the data with respect to age as well as with respect to sex as well as with respect to ethnicity. And then you can produce more attractive tables for your summary statistics, like using survey mean command and then producing a F table that is called flat table. So for example, we can find interaction between sex and ethnicity and then find the proportions, that is called cell proportion, using cell proportion command. It's again taking time as we have uh, a huge number of data. You can just see cell proportion like this. Now we uh, have the same table with the proportions within different classes and the standard deviation. Now this time if you see, the proportions are obtained based on all total number of observation, not on the basis of the row or column. So keep in mind this interaction table is giving just the proportion of cell from divided by overall data, not the row total or column total. And you can just find write this table as you can give f write as f table, and you can give the row names like sex, male and female, and ethnicity, these, and you can just write this command, and we are basically finding cross tabulation, that is cross tab we already obtained above. You can just write cross tab. Let's see how you can produce a cross tab with different label names. Basically we are giving names. Now this is a compact table, you can just report it to your uh, publication. Right, we have ethnicity, and then we have sex, male and female, and ethnicity. We have means, and we have standard errors. We have means, and we have standard errors, and so on. So this is a compact table for a two for uh, for interaction between two variables, and we are just naming the ethnicity and sex. We are just labeling at this stage. But I already said you can label your variable values in start. That will be easy, and you can just use proportion table and just write f table for the proportion table. You have already produced here. This is most appropriate, and followed by chi-square test of association. Basically, in most of the cases we need to report the proportion with respect to row or with respect to columns. We are rarely interested in proportion from overall data, basically from the total sample sizes. That is rarely we need it. So this table gives the proportions for overall table, and you can see the cross tabulation. And similarly we can find it table for mean for uh, continuous variables, like you can basically uh, produce a table for mean ages and mean income by sex and ethnicity, and you can just produce this table. This is the same table which we have already produced, but you can write it as flat table, and it will give you a more attractive view. And you can just name the rows with different labels, like and this is sex male and ethnic group 1, and this is sex female within ethnic group 2, and so on. So you can just copy this table and report your result. So that's all about today. These are all about the presentation of data in tables for quantitative as well as qualitative variable. If you have any concern, or you want to learn more about producing more stable tables, you can just write in comments. Thank you.